Hi everyone, here are your notes for section 8.2 today. We're going to be starting chapter 8, which is talking about all different types of quadrilaterals. So we're finally moving away from triangles. I know we've been with them for quite some time, but now we're going to add a fourth side and move to quadrilaterals. So we're going to talk about all the different types of quadrilaterals that we can have. To start out, we're going to focus specifically on parallelograms. So what do we know about a parallelogram? Well, the definition of a parallelogram is that it's a quadrilateral with both pairs of opposite sides parallel. Hence why we call it a parallelogram, right? So these sides are parallel, these sides are parallel. Then we have a bunch of theorems that have to do with parallelograms. So our first theorem we have states if a quadrilateral is a parallelogram, then its opposite sides are going to be congruent. So you might want to recreate this picture in your notes. So the left and the right sides are congruent to each other. Remember, that's what those tick marks mean. And the top and the bottoms would be congruent to each other. Another theorem tells us that if a quadrilateral is a parallelogram, then its opposite angles are congruent. So angle P is congruent to angle R. Remember, that's what those single arcs mean. And angle Q would be congruent to angle S because they are opposite of each other. They would be congruent. So let's go ahead and utilize these two theorems in practice. So for example 1, we're going to solve for the values of x and y. So let's start with the x first. X up here has a +4 attached to it. There is not a little degree sign there, so that's telling me that it is on a side length. Well, because it's a parallelogram, I know it's a parallelogram because I've got opposite sides. Remember those little triangles means parallel? So those opposite sides are parallel. These opposite sides are parallel. Because it's a parallel, then I know opposite sides will be congruent. And when we have congruent things, we just set them equal to each other. So I'm going to take my x plus 4 and set it equal to 12. Subtracting 4 gets me x is equal to 8. Now we need to solve for y. Here is my y. Notice y has a degree sign in it, so that means it's inside an angle. So what did our theorem tell us about angles? It tells us that opposite angles are congruent. Well, y is opposite of the 65-degree angle, which tells me that y should be equal to 65. Example 2. For what value of x is the quadrilateral a parallelogram? So what would x need to be in order for this to be a parallelogram? Well, opposite angles are congruent, so x would have to be 66. All right, I think we've got those two theorems covered. Let's move on to a third. Our third theorem in this section says if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. Do we remember what supplementary means? Supplementary means they add up to 180 degrees, right? So if I look here at this diagram, consecutive angles are angles right next to each other. So those two angles are right next to each other. Remember consecutive interior angles back in chapter 3? So they are supplementary to each other, so x plus y should equal 180 degrees. These two angles of x plus y should equal 180 degrees. These two angles of x plus y should equal 180 degrees. And the last set, these two angles of x plus y should equal 180 degrees. So looking at this example, find the measure of angle B. Well, angle B is here. The only other angle we have is C. They are not opposite of each other, so they cannot be equal, which makes sense of that. C clearly is acute. B is clearly obtuse. So there is no way that you will ever have an acute angle equal to an obtuse angle. So we know that they have to be supplementary. So I'm going to do 180 minus 51. Do some math. So that tells me that the measure of angle B should equal 129 degrees. Example 4, for what value of x is the quadrilateral a parallelogram? So, I'm back. There we go. Because we have two angles that are not opposite of each other, like if this angle was over here, then I would set them equal to each other. But they're not opposite of each other. They're right next to each other. So we're going to add them together. So x plus 10 plus 2x plus 20. And then if those added together equal 180 degrees, then we would have consecutive angles supplementary, which makes us have a parallelogram. So let's go ahead and combine our like terms. 1x plus 2x makes 3x. 10 plus 20 combines to make 30 is equal to 180. Subtracting 30 from both sides gets us 150. Dividing by 3 from both sides gets us 50. So if x was 50, then that shape would be a parallelogram. If x was anything but 50, then it wouldn't be a parallelogram because your consecutive angles would not be supplementary. Last theorem for this section tells us that if a quadrilateral is a parallelogram, then its diagonals bisect each other. Do we remember what bisects means? Bisects means cuts in half, right? So here's a picture of the diagonals. So diagonal PR goes from P to R. So we're just connecting opposite angles. When I get those points of intersection, they're going to cut each other in half. So that top half of Q to M is going to be the same as M to S. And P to M is going to be the same as M to R. So moving into our last few examples here. Here again we have a parallelogram because we've got the triangles showing us. We have the diagonals put in place. So diagonals will bisect each other. So that means that this half is the same as that half. So I can set those equal to each other. So A is equal to 2A minus 8. Subtract 2A from both sides, gets us negative A is equal to negative 8. Change your signs, A is equal to positive 8. It also means then that on the other side, this half is the same as that half. So I can set those equal to each other. So B plus 10 is equal to 3B minus 2. Subtract a b from both sides gets me 10 is equal to 2b minus 2. Adding 2 to both sides, give myself some space here. Adding 2 to both sides gets me 12 is equal to 2b, so b is equal to 6. So a is equal to 8, b is equal to 6. And then for our last example, it says, for what value of x is the quadrilateral a parallelogram? So again, if it's a parallelogram, then the diagonals are bisected, which means they're cut in half or into two equal parts. So I'm going to set them equal to each other. So 5x minus 8 equals 3x. Subtract 5x from both sides gets me negative 8 is equal to negative 2x. Dividing by 2 gets me x equals 4. So if x was 4, then those diagonals would be bisected, which would make it a quadrilateral. That concludes your notes. Have a good one.